and I'm just going to promise whoever's listening that I am in fact here. But anyways, the reason this all got messed up is I realized on the videos the screen was too small, so I just made it bigger, which then threw everything off. Anyways, I am here. All right. Nope. So first, here's the first thing I want to make sure is clear. And I added some wording to the lecture, the student lecture task description. The PR, everyone look at me so I know you're listening. The pull request merge date is at least 1 day before the day of your lecture. Merge means when it's accepted. If you submit a pull request the day before, first of all, if you submit a pull request after 4 p.m. the day before, it's not getting merged. I'm at home with my family. And after 4 p.m., I don't care about any of you. At 9 a.m., I care. After 4 p.m., I don't. So it ain't getting merged, and I'm going to be very unhappy, and it's not going to go well for you. It is possible that you submit your pull request the day before, and I look at it, and I'm like, wow, it's perfect. Accept, merge. Don't expect that to happen. Submit it, expect there to be feedback from me. You're going to mess something up. And I might have feedback on here, improve this, do that. And that feedback is just giving you more points. I give you feedback, you do it, you get more points in the end. So this is a good thing. It's basically going to guarantee everyone gets close to the 10 points for the lecture anyways. But this does not mean you have to submit the day before. No. You're probably going to want to submit well before the day before, so I can read it, give you feedback. You incorporate the feedback, you push the changes, I read the changes, maybe I have more feedback for you, okay? So I said merge date is the day before. Submitting your pull request should come in well in advance, such that you can easily merge the day before. Is that clear? Cool. So, now that that's done, project. All right. I am going to just go through this really quick. Maximum points, 30. It's okay, to be clear, it's basically an assignment. It's just an assignment, but you can work in twos if you want. You don't have to, but you can. And you have a choice to do a presentation or a report. Right? So if you want to give a kind of like another lecture, just instead of writing a report, but the lecture would basically be your report, you can do that. And if you do, then things like the pull request date and the merge date, those are applicable. If you don't want to do a presentation, that's fine. You could do like a report, and then that's not relevant to you. Yeah. Well, it would be like a presentation. So it wouldn't be like a lecture in the sense of like you're doing a lecture on a topic. You'd be doing a presentation on what you did in your project and the results you got. Is that what you're, yeah, what?
I was just going to ask, like the report would have to be in latex format.
Yeah.
The presentation could just be.
The presentation?
PowerPoint.
No, the presentation would have to be like the lecture, and it would go on the website. Because what I'm going to do is I'm going to like store all past student presentations. So this year, if you go back to like the main page, 340. What I've got here, everyone's lectures will be under here, so anyone can see just for fun. But what I'm going to do for future years is I'm going to have like subdirectories where it's like, okay, these were the presentations in fall 2023. Then these are the ones from fall 2024, right? Just so it's there.
And then how long should, like, if we're going to do the presentation for the project?
How long should it be? Like 15, 20 minutes, right? Usually, so when I say 15, 20 minutes. Pardon? Well, what you would do, so the way I'm envisioning, you know what, how about I go through it, and then when we get to the specific parts, because I think I'm going to answer some of these questions. I like your enthusiasm, though. That's wonderful. All right, don't cheat. Base task. So, and the other thing about this project as opposed to the assignments is here, it's up to you. What you want to do, entirely up to you. Marking details, it's like the same. The way the points are going to be handed out for the presentation or the report is a little bit different, but it's the same general idea. Project topics. It's the student's responsibility to select a project topic or the group and have it approved by the instructor. Once approved, the project direction is up to the student. It's entirely up to you. If you're like, hey, I'm thinking of doing something around like this topic, and I go, awesome, go, you do whatever the hell you want around that space. It's entirely up to you. I'm going to give you very minimal direction. The only way direction is going to come up is if two groups or two people want to do like the same thing. Then what I might be like, okay, so you both want to do this, but how about you do it this way a little bit, and you want to do the same thing, but you're going to look at it this way a little bit, right? Just to make sure it's a little bit different. So there might be a little direction there. You're encouraged to be as creative as you want, be ambitious. And the reason I'm saying be creative and ambitious is just like everything else in this course with your assignments is having a wacky harebrained idea that doesn't work, you're not going to lose marks for that. Trying something interesting is going to get you good marks. If it is successful or not, it's still going to get you good marks. So don't be worried about having a wacky idea that is if you have a wacky idea that really is like, okay, why did you think that would work? You're an idiot. Then yeah, maybe we've got an issue there, right? I'm not expecting that to happen, right? If you can intuitively rationalize why someone would do what you wanted to do, yeah, you're going to get the points, okay? And if you look at your marking for assignment 1, you'll see that like the marker is looking for excuses to give you marks. They're not looking for excuses to take marks away. That's the whole point of this. That's the reversal of this course, right? You get points for doing shit. You don't lose marks for doing things wrong, right? So we want marks to give, we want to throw marks at you. Most project ideas in the past have fallen under like an application, like, okay, you know, I'd like to try to throw like a genetic algorithm or a particle swarm at this project, this problem I'm particularly interested in. Cool. Some people are like, hey, I've got this crazy idea that I think if I, like a pretty big idea that I could throw into, like incorporate into genetic programming and I think it's going to improve results. Do it. Or some people are like, okay, given the idea of evolutionary computation, what if I just take that high-level idea and implement the algorithm entirely in a wacky different way and come up with a whole new algorithm that is evolutionary computation because it follows those principles? Have at it. Usually they fall within those, but it's entirely up to you. Don't be afraid to try something different. I like the creativity. Topics, first come, first serve. If multiple groups want to do the same thing, I might direct them a little bit. All topic choices, along with the preferred presentation date, if choosing to give one, are to be submitted to the instructor via email. The date for that is the 25th. That is, what, a week today? A week today. So you've got a week to think about what the hell you want to do. I don't think I've ever said no to a project idea, by the way. So if you're worried, don't be worried. Now, part of the points, the mark breakdown is for like modifications, enhancement, novelty. This really is hard to explain in the context of the project because it's really going to depend on what you're doing, right? If your whole project is an enhancement on an algorithm, well, giving you points for more enhancements is kind of silly. No, it's going to be more, this is more, again, I want to give you marks. So just impress us, give us excuses to give you marks, you get more points, right? Yay. Project presentation, points will be you're only going to get points for either doing a presentation or a report. I briefly considered making you do both, but then I was like, I don't know. I don't want to read your reports and listen to your presentations, so you only have to do one. If you're thinking it's because I'm nice to you, no, I'm selfish. Groups may choose to give a 15 to 20 minute presentation. The presentation will follow the same general format as the report. So think of like one of my lectures, except the first is like, okay, here's the problem and here's what I want to do. Here's some related work on it. Here's my strategy on how I'm going to, so you're basically giving a presentation of how like the report would be formatted in general, but it's entirely up to you how you want to do it. Okay. Presentation dates, again, first come, first served basis. These are the last 4 lectures before the end of the semester. The reason there's only 4 dates here is I'm assuming some people, raise your hand if you're thinking as of now. There's 1, 2, 3, 4, 5, 6, 7. There's 4 people missing. I'm assuming, raise your hand if you're thinking that, yeah, you want to work in a group. Interesting. Huh, all right. Okay, well that might affect the dates. And raise your hand if you're thinking, I think I want to do a report. I don't want to do another lecture. Okay, perfect. So then we don't have to deal with.
Can we do like both and then get to one more?
No, you can only do one or the other. Remember, because I'm selfish and I don't want to mark both. Okay, but I like, good question. So basically, raise your hand if you do want to do a presentation instead of a report. If you're thinking, 1, 2. So as of now, it looks like we only need one of these days. So we've got flexibility. So that's why I didn't make sure there was enough for each person to do a presentation. I figured there'd be some wiggle room there. So that's good to know. You don't need to pick a presentation date, obviously, if you don't want to do a presentation. Points, yeah, whatever. Submitting a pull request, again, if you're doing the presentation, don't submit the pull request the day before and expect me to merge it. It ain't gonna happen. I don't want garbage on my website, all right? I'm not paying to host it. Reports, you can do a report. It's the same as everything else you've done. What to submit, anything relevant, cool. So that's the idea for the report. Yes?
So for the report, just submit a PDF on the due date, and that's like nothing with like multiple pull requests or all.
Nope, you don't have to deal with the pull request.
Sounds good.
You think that's easier? I figured doing the website would be way easier. Because the website, like the lecture topic, it requires, like, look. Let me show you here's why I thought doing a presentation would be way easier than doing a report. Okay. Here, I'm going to tell you how when I write a paper, those reports that you're writing are like scientific papers. They're formatted to be as such. So here's how I do my papers. Here's my advice to you. Have I told you this advice already? That doesn't sound like it? Okay. Here's how I do it, because I hate writing. But when you're writing stuff like this, it's technical writing. You're not writing an essay. And if you write a scientific report like an essay, everyone's going to hate you. So if you're like, oh, I hate writing, oh, essays, I'm with you. Scientific writing is technical writing, and technical writing is way, in my opinion, simpler. It's basically 1 degree above point form. So here's how I start all of my papers. All of the papers I've ever published, this is what I do. I start by opening up LaTeX and creating the sections I think I'm going to want. Your typical, I want my introduction, explain the problem, whatever. I'm going to create my sections. Depending on the problem I'm doing, I might need additional sections. But I come up with my sections, and then I think about the subsections. What things am I going to want to talk about? So I put in my subsection. So now I have like a framework. And then what I'll do is I'll look at the intro section, and I'll be like, okay, within the introduction, what are the key points I want to hit? And I will start writing in point form, in overleaf, the key points I want to hit. And maybe I end up with half a dozen points in the section. I go to the next section, another half dozen. The next section, I have a dozen, whatever. I'm filling it in, and I've got all these points. And as I'm going through, I know, I've done this a lot, I know that as I'm on section 7, filling in some points, I'll be like, oh, you know what? I got to go back to section 3 and make sure I say this. So the process of going through and filling out all sections with the points I want to hit. And when I mean point form, I mean point form. I mean like the most brief point form imaginable. I'll be like, okay, explain this issue. Okay, next. Explain why this particular aspect of it's difficult. Right? Like I'm not explaining it, I'm just saying the points that I want to do. Once I've done that, maybe I'll do another pass because, I never sit down and then try to write. I'll make sure I give it the day because God knows the next day in the shower I'm going to think of things I'm going to want to add to it. And next thing you know, I've got all the content that I want to have there. Sometimes when it comes to the results section, I like to usually I literally storyboard my results where I will generate the figures that tell the story I want to tell, put them into the overleaf, and then I just explain them. Next thing you know, I'm done my results section. Then what I do, and I do this with like point forms as well. Then once all the points are there, I'll look at each section and I will say, how do I order them? Right? There's going to be like a cohesive, coherent flow. It's going to make sense. I want to hit this point and then hit this point and then hit this point because they'll segue into each other nicely. Right? And sometimes when you're doing that, it ends up making a nice natural way to go to the next section. So you just order them in a way. And then maybe I'll even order them in such where like, okay, these 3 points can actually be in one paragraph, and the next 2 points should be like these next 2 paragraphs. And then, so I'm just generating the layout. And all of that, it sounded like a lot of work, but all of that is the easy part for me. Because I'm putting down ideas, that's it. I'm brainstorming. It's effectively brainstorming. Then it's the hard part for me. Then it's basically turn those points into sentences and turn those sentences into paragraphs. That's it. I know it sounds like the last step is the easiest to explain. Turn those points into sentences and paragraphs. The next thing you know, and then once you're done that, you're done your paper. Sure, you do some edit passes, of course, you want to make sure it's nice. But to me, that's the hardest part. All of the other things where I know I had a lot of detail in explaining how I do it, but to me that's the easy part. The hard part is turning them into like actual writing. But it's not fancy writing. It really is just 1 degree above the point forms. That said, look at how I do my topics. Here, today we are on genetic operators. I think this is a particularly big topic. My lectures are all the easy bits. Literally, it's point form. I just do point form. That's all. If you haven't noticed, all my lectures are just point form. I can explain these points to you when lecturing in more detail, but doing that in writing, to me, is the hard part. So this is why I thought doing the lecture would be easier, is I just do point form. I came up with the points I want to have in my sections. I order them in such a way, and then I'm done. Sure, okay, I add some figures, fine. Half of them I steal from other places, whatever. But that's it. And of course, if you read through like the lecture stuff, this point form, literally this markup right here, it's called restructured text, is what it generates this website. Let me make sure that's obvious to people. So there's a markup language called RST, restructured text. It is like the markup language for Python. And so all of the Python documentation is in restructured text. In fact, there's software that will look at like your doc strings of your functions to generate documentation automatically for you in restructured text. So restructured text I like because I find it to be this arguably the simplest markup language to use in terms of like what it looks like. When I'm writing it, it looks like this. Like there's no like HTML tags or any nonsense in there, right? It's nice. It's just point form. Ooh, I got fancy and added a heading and a section and a subsection and a subsection, right? And then every once in a while I have a figure. This is probably the most complex bit. But then I use software called Sphinx, which is like the Python software Sphinx that just turns that markup to the website. It turns it into this. That's how you're going to do your lectures. Now, if you download the repo, which if you're going to if you're doing the lecture, you want to, fork and download the repo, install the virtual environment, you'll have Sphinx. It's there. And if you read the README, it tells you how to build the website locally, which is, you go to the README and it's sphinx-build-b HTML source directory, output directory. Right, so it's just one line, enter, it builds locally. But when you submit your pull request and it gets merged, there's some GitHub actions that automatically do all that for you. And it pushes it and updates the website like that. It's pretty cool. Any questions? Yes.
So I got, so if you do the presentation, you kind of get like the feedback from like uploading it and then you reject it. Could, like, if we're doing the report, could we like come to your office hours and get like, how do you think the report's looking so far? Do you think it looks good? Like that kind of.
Not in as much, you can,
Okay.
but it probably won't be as much detail as I would do it with the pull request, because with the pull request, I'm gonna be sitting down, I'm gonna be at the computer, I'm gonna be I'm gonna be focused on it in my zone, and I can, go through it. The report, not as much. We can do that for sure, but you're not, I'm not saying this because I'm saying no. I'm saying this because I know my ability to give you the feedback on the report is not going to be as easy as it is for me to give you the feedback on like the pull request.
Yeah, makes sense.
So for accepting the pull request, I mean, you accept the pull request?
I have to accept it, yes. So you submit it, and maybe when I'm going through it, I might say something like, and this could be for the project or the lecture. I might be like, oh, there was a typo there, some grammar there, little things like that. But maybe it'll be like, I think you should explain this part in a little bit more detail. And so like on a pull request, I can actually, like, when I give you feedback, I'll give you feedback on like specific, like I can say, I'm giving you feedback on lines 17 through 22. Like, oh, I think you should explain this in a little bit more detail. I think you have an opportunity to really hit this harder, right? And then, okay, and you can reply to it. You can say, like, the reason I'm not is because X, Y, Z. And then, oh, okay, all right, fine, right? So on the feedback, on pull requests, there can be a discussion. I encourage the discussion. If you don't agree, explain why, and then if I agree with you, I'll be like, oh, okay, if I continue to disagree, I'll explain why I continue to disagree, right? But, you're just getting experience using GitHub, but that's a good thing. Yeah. And then once it's good, I'll merge the pull request, and yeah, there we go. Other questions? All right. Now that we've spent a lot of time on this, but I think that was good. Let's talk about some genetic operators. So first and foremost, we've talked about a genetic algorithm so far. And there's a lot of types of evolutionary computation out there, but a GA, I would say, is of all forms the most popular, and it's fairly general. I'm going to talk about genetic operators for a broad collection of algorithms and representations. A lot are going to be focused on genetic algorithms, but they can be generalized. The ones I'm showing you, if it hasn't been clear so far in this course, that there's no right way to do it, there's not. I'm not showing you these genetic operators because these are the ones I want you to use. I'm showing you these genetic operators because there are some people have used. And it gives you ideas of what can be done. So that's the point. So it's obviously not an exhaustive list. It shouldn't be assumed that they're particularly good. They are intended to provide foundational ideas. The focus is on GAs. Yeah, creative and new is good. Okay, good. Crossover. So of course, in the context of genetic algorithms, we're talking typically about your crossover and mutation. And you might remember earlier in the semester I was talking about how there's like explorative and exploitive, right? And some people will say, well, mutation is more exploitive. You exploit what's really good. Or no, crossover is more exploitive because you're exploiting two things that's very good and you hope you get something good. Mutation causes wild, different changes. It can jump to the other areas of the search space, so it's more explorative. People that do that are using these labels wrong. They're trying to come up with these absolute terms. No, it depends. It depends on what the crossover is, what the mutation is. It all depends. These are not absolute terms. They are relative terms, okay? So we could talk about crossover for binary representation, and here's an easy one. 1-point crossover. I think this is the one we did in the first bit string example. Here's an example of two parents. For demonstration purposes, one is full of zeros and the other one is full of ones. They could be, whatever they are. But you pick some index at random and then exchange the values between the chromosomes after that index. Great. Cool. Now, this particular crossover is not all that destructive. Destructive meaning, and again, destructive is a term that you can't use in an absolute sense. You have to use this term in the context of the algorithm you're using on the problem you're using and the representation you're using for that problem. If you're doing something like TSP and you did a one-point crossover, that is a hilariously bad idea. That is going to be very destructive because it's almost certainly going to destroy the whole permutation property. It's very destructive. But on something like a bit string, it's hard to really say because it depends on what this encoding is what is the phenotype for this genotype. It really depends. But in general, typically, this one-point crossover is not particularly disruptive. It's destructive. It's not going to wildly destroy your population with a change like this. It works particularly well when element adjacency is important, unless it's like TSP where permutation is an important thing. But maybe the fact that these zeros are next to each other is important. Like adjacency is important, assuming this is a good candidate solution, and this is another good candidate solution, they were both selected, and assuming what made them good was the fact that these elements are next to each other, only at like one point do we have like an abrupt shift, meaning overall not that destructive. And then we can generalize this to n-point crossover, where n can be, honestly, whatever you want, 2, 3, 4, 5. Where you pick some arbitrary n, you pick that many indices, and then you swap between like every other pair, right? So we swap between these two and then these two, right? And whether it's even or odd, all just depends on do you swap between the last two indices or the last index in the end. N-point crossover, there. It's a little bit more destructive, relatively speaking, to one-point crossover typically, but there we go. Uniform crossover, here, this is effectively like n-point crossover, maybe not quite, but basically you just randomly, you go through each gene, each allele, each index in the chromosome, and you go, do I flip them? Flip a coin, yes or no? Yeah? All right. Do I flip them? No. And so on. Okay? Mutation for binary, bit flip. There. If it's a 1, turn it into a 0. If it's a 0, turn it into a 1. Now here, this particular example had the parent only containing 1s, meaning they all, if they flip, they'd change to a 0. But had the parent had a 0 here, it would have flipped to be a 1. Okay?
What is the difference between genetic operator and genetic algorithm?
A genetic operator is crossover or mutation. A genetic algorithm is the, your initialization, stopping criteria. How do you evaluate fitness, selection, and genetic operators? Genetic operators are just a part of these algorithms, but a big part, because there's the two big competing things here. There's like the selection pressure and the variations. And so, yeah. Obviously, this is not an exhaustive list, but yeah, there's some genetic operators for some binary representations. Now, for integer representations, where integers, now, when you have an integer representation, it could be, it could be that your encoding has the integers between 0 and 10 for some reason, or maybe it could be any arbitrary integer, whatever. But for the most part, all of the, like one-point crossover, uniform crossover, n-point crossover, they're very popular for integer representation as well. They work very well for integer representations. So yeah, the crossovers used for binary representations are typically also used for the integer representation. So that's easy. Mutation, well, we couldn't really do a bit flip. Because if I'm allowed any integer and I pick an index and I say, okay, flip it, you go like, to what, right? So the variation we use is single point mutation. Sometimes they'll call it random resetting. Basically, you pick an index, and instead of flipping it from a 0 to a 1 or a 1 to a 0, because it's not a binary representation, you just randomly pick from the set of allowable integers and just replace it with a new value. I pick index 7 that happened to have the value 102 in it. And then I picked a random integer, negative 44, put it in there, there. That's my mutation. Throw something in there, good. And by the way, people will often like generalize these from like single point to be like, well, do endpoint. You know, do this 5 times on a chromosome and call it a day. All right, cool. Do what you want to do. Swap mutation. Wait. Swap mutation. Hold on. Yeah. If order really matters for whatever your phenotype is, well, pick 2 indices and exchange the values between them. Like, just swap them. Remember, mutation acts on a single chromosome, right? Crossover acts on 2 chromosomes. So when we're swapping, we're not swapping between chromosomes. We're just picking 2 indices within the same chromosome and exchanging the values between them. Creep mutation, select an index at random, change the value of that index relatively close to the value it currently is. So again, this is going to depend on the phenotype. What is the problem you're working on? If for whatever reason, the fact that, what do I have? If the value at some, I select some arbitrary index, if the fact that that chromosome is good and there happens to be a 7 at that index, there might be a reason that I think that, you know, doing a, what did I call it? Like a single point mutation, where picking an arbitrary another integer to put into there to replace the 7 with it, sorry, to replace the 7 with. A single point mutation would be pick an index, oh, there's a 7, and randomly select another integer to put in there. But depending on the problem, that might be a really destructive mutation. Depending on the problem, it might make more sense to change it, but change it to something similar to what's already there. So if it's a 7, replace it with an 8, or maybe a 6, maybe a 5. Don't replace it with a negative 44. That's too far away. That's going to be way too destructive. But the fact that 8 is close to 7, maybe that's an important thing that I can incorporate in my mutation. Genetic operators for permutation representations. I know a bunch of you kind of explored these already. Raise your hand, though, and be honest. Raise your hand for the TSP assignment, because you were using a permutation representation, probably. You didn't have to, technically, but you probably did. Raise your hand if you used a genetic operator that I already implemented. Yeah, good. Good, because it worked. So if you didn't raise your hand, that means you came up with your own. Raise your hand if you came up with your own. You did, nice. Oh, okay, very good, very good. So these ones are tricky, because you want to make sure that by changing the chromosomes, you don't obliterate you don't obliterate the permutation property. The fact that it's a permutation of the integers 0 through 99. If I change it such that there's no 7 in it anymore and 2 14s, I've broken the permutation property. That's bad. So I got to be careful. And because these are a pain in the ass to explain, let's start here on Friday. Any last questions before we go? These are a pain in the, okay, here's what I want to ask though. Okay, raise your hand if you use, what was the one I had implemented in the crossover? No. That was swap mutation. Order crossover? Okay, order crossover. Who here looked at that and was like, I understand it completely? Or who here was like, it says it works. Which one were you?
After an hour, I understood.
After an hour, you understood? So it's really not that bad, but yeah, it's not as easy as the other one. So okay, raise your hand if you used it and you're like, I understand it completely. I'm really happy with it. Raise your hand really high. One.
I like to look at the code and try and understand the code.
So that's
I just took the
good.
code
That okay. So raise your hand if you're like, it said it worked, so I used it and it worked. See, okay, there you go. Either approach was fine. I would encourage you next time to figure out why it works. But yeah, and what made me so proud of that particular one is I think I told you all already. Yeah, I had the internal function in that function, which I'd never done before. I knew you could do it in Python, but I've always been like, why would I ever do this? I can't imagine that's very helpful, whatever. Why would I ever do this? And then finally I'm like, oh, I have a chance to do this, and it makes sense to me. This is exciting. So I got really giddy over that. Anyways, we'll end there. I'll see you all later. Have a great one.